Hi, and welcome to Cosmos the Shot. And here's to Earth, Theia, and the formation of the moon.
Oh boy.
Oh, this is going to be weird. Oh, it's not bad.
It's like a chocolate banana.
Yeah, it's really,
Delicious.
it's really good.
Yeah.
I thought it was going to be much harder. Anyway,
Yes.
look up on any given night, and you will see the moon. In fact, there's really only one day you won't see the moon. That's the new moon.
Yeah.
Generally, you can see the moon any other time. In fact, we just saw it last night through a telescope.
We did.
It was a lot of fun. The moon has inspired poems and
Cheese.
cheese, stories, werewolves, our imagination. In fact, it's the only place beyond the Earth we've sent astronauts to, that we've sent people to. 12 people have walked on it. And hopefully, in the not too distant future, we'll have more people who walk on the moon.
Fingers crossed.
Fingers crossed. Yes, indeed. But how did the moon get there? How did it form? These are some of the questions that astronomers have been asking for a very, very long time.
Big cow and a lot of milk.
Yes, indeed. So there are a lot of ideas about how the moon formed. But right now, the main idea that everybody is gravitating towards, is called the giant impact theory. Or pops. Giant impact theory, and it's the most widely accepted one today. And in this theory, hypothesis, whatever, there's a lot of evidence behind it. So I guess it really is kind of a theory.
More theory than hypothesis at this point. Yeah.
Basically, what it says is that the Earth had a big boom. Something ran into it. Big collision.
Yeah, someone wasn't looking the right way.
It wasn't. They ran right into each other.
They were on their phone.
Yeah, exactly. And the moon formed as a result from this big impact. So what is the evidence? There's actually a lot of evidence. By the way, the thing that hit the Earth, about the size of Mars.
Oh, okay.
And I do want to say it was not Mars. Mars is still with us.
No, Mars is around.
But
we see it.
It is called.
So that's about half the size of the Earth, then.
Yeah. So it was called. It was called Theia, and it was about the size of Mars. The early solar system was everything was just
a hot mess.
Hot mess.
Really.
Things flying all over the place.
Dirty,
and so
very cluttered room.
A lot of collisions happened, and this was one of them, most likely. So what is the evidence that supports this? There's actually a lot of evidence.
Okay.
A lot of evidence is actually brought back by the Apollo astronauts
from
in the
the moon.
60s.
So it came from the moon.
Actually came from the moon.
That's always good to have. You want to have probably samples of the moon to be able to say, hey, what's this made out of? Where'd it come from?
Exactly. And the astronauts brought back about 300 pounds or so of moon rock.
Wow,
so a third. No, I'm sorry, more than that. 600 pounds. It was about a third of a ton. So that's about 600 pounds.
That's a lot of.
That's a lot.
That's a lot of moon.
And so, of course, when the rocks came back, chemists and astronomers and physicists, they were all very interested in looking at it and finding out what these rocks were made out of. And they found that the moon rocks, were very similar in a lot of ways to Earth's rocks.
Oh, how could the moon rocks be similar to the Earth rocks if the moon was a completely separate thing?
So chemically and with isotopes, they are very similar to each other. In other words, made of the same stuff.
Okay, all right.
And but there is a little bit difference between Earth rocks and moon rocks. And it's in these things called volatiles. Volatiles are things like nitrogen, carbon dioxide, water vapor, that type of thing. When temperature gets high, they evaporate off. Volatiles. And since there's a lack of volatiles in the moon rocks, that means that the moon when it formed, is a lot of heat. There's initially a lot of heat. And the giant impact theory actually explains a lot of this. And so,
well, it would be hot.
It'd be very hot. So what actually happened? So Like I said earlier, the early solar system was just really chaotic. Things flying in and out. A lot of collisions were happening. And so this Mars-sized object ran into the Earth, and it wasn't a head-on collision.
Okay.
So it didn't hit the Earth dead center.
I'm guessing that's a good thing.
It was a glancing blow. But that glancing blow basically just made what was a solid Earth a liquid Earth, along with Theia. Those two merged, but material got blown off.
Right.
It was a glancing blow, so a lot of material got blown off. A lot of it fell back down onto this now Earth Theia mixture. But the stuff that stayed in orbit would actually go on to form the moon.
Right.
And so the question becomes is how long did it take for the moon to form? And it's really interesting because when I started off in the planetarium field, it was they're talking millions of years for the moon to form. But then by the time I left one of those planetariums, it became maybe just months.
Wow, that's fast.
Yes, but there was
That's
a computer
really
simulation that NASA just recently did, and this is the highest resolution computer simulation of the moon formation. Hours.
Yeah. It came together in hours?
So it came together. It wasn't solid.
It was just like hey, all these pieces they needed to kind of just
an object
and merge fully.
An object that was about the size
of the
moon.
A pile of moon.
A little liquid pile of magma and stuff. But yeah, and so that came together within hours.
That's fast. That's wild.
Yeah. Sure, it needs to be looked at some more.
Right.
But that is absolutely insane, and it formed about only 24,000 miles away from the Earth, which is 1/10 of what it is now, 240,000 miles. So pretty close.
Pretty close, yeah.
Tidal forces have made it move out further over time.
And it's going to keep getting further
away. It's going to keep getting further away.
Goodbye,
the impact itself was 100 million times greater than the one that killed the dinosaurs.
100 million times greater? 100 million times greater than what killed off the dinosaurs. That is unfathomable. Even the impact that killed the dinosaurs is unfathomable.
I know. And that's all you need to make a moon. You know?
That's all you need to make a moon.
That's all you need to make a moon.
Step 1, two objects minimum. Step 3, just a hard impact.
Yeah.
100 million times greater than the impact that killed off the dinosaurs.
Yeah. And
Step 4, gravity.
Exactly. But, so the moon is pretty big. And it's, quarter the size of the Earth? Something like that?
Sure.
And there's got to be a little bit more than that because it rivals Mars in
bigger
size
than Pluto.
in a way. It's bigger than Pluto. And if we didn't have it, the Earth
would be fucked.
Well, we wouldn't be here. The Earth would.
Well, yeah.
But it would be spinning wildly. And so the moon stabilizes our orbit, our spin, allows us to have regular seasons. They would be really unpredictable if we didn't have the moon. Allows life to exist.
Dogs. We get dogs because of the moon. We get dogs.
We get people too.
Well,
so
we'll take dogs.
Good with the bad, I guess. And that is the story of how the moon formed.
I love it. Thank you, Moon. Well, thank you, Theia, for just not paying attention, being on your cell phone and causing that crack. But for real people in real life, pay attention to where you're driving. You don't want to have form a moon of a car.
No, we don't. That would be cool, but it's not going to happen.
No, we don't want that.
No. All right, cool. Check us out on all the things. And, we'll see you later. Follow us on all the things. Cheers.